My name is Jason.
And I'm Dan.
And I'm Paul. We decided using the Nepean Storm Creek to somehow clean the water before it reaches the river. Our original plan was to create a big filter platform. The platform would be used as a snow dumping facility. And as the snow melted through it, it would be cleaned out. Problem is, we ran into is that we could not stop the salt from being filtered through. Therefore, we refocused our ideas to use the original Storm Creek as it is. Right now, it consists of a settlement pond which overflows through a dam and into the next one, eventually reaching the river. We want to use these dams to create a filter.
Now, before knowing exactly what we needed to, how to design our filter, we needed to know what to filter out. So we visited the Nepean Creek to take samples of the water and to see what type of contaminants affect the water in this system. As you can see in the picture on the left, our water samples were full of contaminants. In our visit, we saw that various pollutants affect the creek. We saw hubcaps, brake lines, beer cans, tires, animal feces, and oil, different kinds of oil, I guess, skimming on the top of the water. Knowing that we had small particles to filter out, we tested various different natural aggregates and found that concrete sand was the most effective material to use to filter out small particles. Knowing that, we needed to figure out exactly how to apply sand to our filtration system, as it cannot be loosely used. We put this into a different kinds of fabric and found that the geosynthetic fabric that is used in road construction was the most effective material to hold the sand together while also filtering out small particles.
Alright, so we made a little pouch with
So
the
this is
concrete
just
sand
a
that
little
we're going to pretty
video
much have
of us running
as
our
our test.
first test with
So this is
sand
pretty much the
bag
same
where
geotextile
we
and
originally
sand that you'd find in the
had
actual bag that would be in the
water that we were
filter.
going to test
And we have some
from
of this disgusting water
our
from
contaminated pond
the
here.
creek itself. And we're going to
And
run
this
it
is what we were running
the sand and the
through our
bag.
sand originally.
And we're going to see what it's going to look
This
like
is
when it comes to
concrete sand that we just took straight
Alright, let's run this
from
test.
the bag and put it into this geotextile bag.
And this is water directly from the Nepean Creek.
It's got some pretty dirty water going through the
It's
sand
not
bag.
like particularly like
Yeah.
dirty in terms of
You want to see it percolating through the sand and then
I can feel it like in my hand.
dripping through the fabric of the cloth. I guess it takes a little bit before
there.
There we go.
Oh, it's so dirty. What?
What?
So
It's
this
so
isn't quite the
brown.
results we were
When
expecting.
it came in,
The
like,
water
look at the water.
That looks way
turned
worse
brown,
when it came in.
I know.
which is clearly not what it's
Look at the
like
water, it's like
in the
look at water
bottle.
floating on top of it, like just-
So what we
Look,
decided
you can see
was
the
we had to
sand.
try it
It's not, like,
again.
actually that
And what
dirty.
we originally thought
It's, like,
was
going
that
through and it's-
Muck out of here.
it was in fact the sand itself that was causing this discoloration. So we figured if
You
we
know what
tested
the
again,
problem is? It's probably,
eventually
like,
all the
sand
fines,
itself
all the
is-
silts
It's like
and whatnot that is
Maybe a
caught
bit
on
of
the
the
sand
fines coming out.
particles
The
would
sand
get
is
washed
just
out.
being cleaned. It must be the silt or
yeah.
the fines of the sand just being
Yeah.
cleaned out. So after that, it'll be fine.
So maybe after a couple runs.
Yeah. Let's do it. So this is
So,
the fifth pass.
After
of
running it
the,
through several times,
sand
these are the two.
compared to the third one.
This is number 3,
Yeah.
past
And
the
that's
third
the
pass,
compared
and this
to
is the
five.
5th pass.
So you really
through
get
the
an
same
idea
sand.
After, say, one heavy rainfall with constant flow for a couple of hours.
And as we mentioned in the video, as
how
you can
clean
see,
the sand
there
patches
aren't
would be
the contaminated water, even though we were using it the whole time, did not pass into our samples.
No
There
suspended.
are no suspended solids,
Nothing that you can see at least. Like all
while
the
when we
stuff
showed
that
the
you
bottle,
found in
there were plenty inside.
That's right.
nothing at all.
So the filtration does work for the
This is
solids.
an encouraging
Yeah.
result, knowing that the
we
sand
hope.
and the geotextile cloth have held back solids. Knowing that, we were encouraged by that, but we needed to know also how to hold back the larger pollutants and contaminants, such as the hubcaps that we mentioned earlier, and floating beer cans and other plastics. With that in mind, we decided to use a natural fabric called burlap. We decided to put a large burlap cloth and lay it over our system so that it can be easily collected with the debris inside of it and discarded and replaced on an annual or semi-annual basis. This would be depending on our testing.
So, after completing our design of the filtration system, we needed to check, will it actually work with the existing dam system, as you can see in the picture here. So what we needed to make sure is that we're actually going to be helping the existing system by adding this filtration system in instead of kind of damaging the entire surrounding. So our proposed filtration system would consist of 2 layers of gabion, one on this side of the dam where the water is flowing through into the other pond, and one on the other side as well. In between these 2 layers of gabion, the aforementioned geotextile sandbags would sit right in the middle here on top of the actual dam weir, which is, like you see the cross section here. So the sandbags would sit in a neat layer right across this, and the gabion would sit on this side and one more on the other side for support, with the sandbags essentially nestled right inside in between the 2 walls. So our gabion walls, this is what they look like. They're essentially just large metal baskets filled with large stone or rock. And generally in civil engineering, they're used for structural purposes as retaining walls and whatnot. But in our case, they're used, one, to support the sandbags in the middle so that they don't become loose and don't dislodge if there's a large volume of water. But we also decided that they worked very well as large particle filters, because there's large gaps in the stones, and as water filters through it, all the larger debris would get caught on the outside, so that only the smaller fine particles are actually reaching through to the sandbag filtration system, and most of the large stuff is caught on the outside. This would help with our projected longevity of the actual system in its entirety. So to figure out whether or not these gabion systems and the sandbags will actually work well with the structure, 2 things we needed to consider. One was if the soil beneath the actual dam would be able to support the load that we're adding to it, and the other is, will the entire dam system overturn due to the increased addition of weight on one side or the other. This is pretty much why we chose to do the 2 walls, as that will kind of essentially balance out the entire equation. So overturning will not occur. And it also helps, like I said, to keep the sandbags safely nestled inside. And we calculated, after we went through all the calculations, that the bearing capacity of the soil, even in the most extreme conditions when the water level is at flooding levels, and with the soil beneath the footing being the worst possible form of soil, which will be determined to be clay because of its low bearing capacity, and it's pretty common in the Ottawa area. And even after all that, the bearing capacity still is okay, and that this structure the soil will not fail under the weight of the structure.
We decided to analyze the cost by material only. The material to do so consists of 3 things: gabion baskets, sandbags, and burlap. As you can see in the table, we included basic dimensions of these materials, and also the unit price of where we got the pricing done, and then the amount that we need to do so, giving us total pricing.
When we made a model that was not exactly to scale, but using the exact same materials that we would use in our life-size model, we were very encouraged by the results that we found. With small gabion baskets and sandbags in geotextile cloth and a burlap in front of the whole system, we found that the pond water that we dumped into this container on the left became much clearer and with much fewer contaminants and pollutants floating around in it as it passed through our system and ended up in the container on the right. This indicated that our system was working as a whole and very effectively, and the small contaminants were being held back by the sandbag and the sand, as well as the gabion structure and the burlap cloth that we had in place. We were very encouraged by these results and found them to be successful.
So After finishing with all the results and our little model testing, we decided that yes, the filtration system should be implemented into the existing pond system. However, since our testing was done on kind of a closed system that wasn't open to any of the elements or anything and wasn't done over a long period of time, we recommend that only one of the dams at the Nepean Storm Creek should have this filtration system added to it, because the system would still need to be tested in the field for A, its longevity, B, how it would react to the elements, how often it would have to be maintained. This kind of stuff we weren't able to actually accurately predict with our small scale model, so we recommend that initially only one dam have this filter implemented to and tested over the course of, say, a year, to see how it reacts and how the water actually is, how cleaner the water gets from one side to the other over the course of the year.
In conclusion, the initial idea was very broad, and after refocusing our objectives, we were able to come to a very doable solution to a very relevant issue that affects our city. Hopefully this idea will be taken into consideration by the City of Ottawa. Thank you for listening.